Since the Industrial Revolution, we have struggled to maintain a balance between a prosperous industry and a flourishing environment. To see an example of this, one must look no further than the Potomac River, flowing from West Virginia, forming the border between Maryland and Virginia, and flowing out into the Chesapeake Bay. Decades of uncontrolled growth in industrial mining, combined with irresponsible mining techniques, caused significant damage to the Potomac River towards the middle of the 20th century. In this video, we will be discussing the events that led to this situation, as well as the numerous attempts that have been made to alleviate it.
We will be concentrating on the section of the Potomac River that has been most affected by mining, the North Branch. The North Branch borders Allegheny and Garrett counties in Maryland and Grant and Mineral counties in West Virginia. The North Branch watershed covers 230 square miles and was, prior to the industrial abuse, the largest trout and smallmouth bass fishery in the eastern United States. Water flows from the North Branch south, eventually into the Chesapeake Bay, which is the largest estuary in the United States, an invaluable natural resource.
In the late 19th century, Henry G. Davis, a retired U.S. Senator, purchased much of the land in the North Branch watershed area to develop into mining operations. By 1892, the Davis Coal and Coke Company was one of the largest in the world. Their large industrial operations included development of railroads and towns, entirely built to house workers and support the mining in the region. At a certain point, Davis's company operated 9 mines and 1,000 coke ovens within a 1-mile stretch.
At first, mining in the Appalachian region was done by digging large tunnels under the mountains. Carts, drawn by mules, would pass under the mountains as workers would manually extract coal, eventually digging more tunnels once resources were depleted. This technique created a massive maze of mining tunnels throughout the mountains along the North Branch of the Potomac River.
Later on, once the coal under the mountains was either depleted or inaccessible, various techniques on the surface of the mountain were used, including strip mining and open pit mining. More recently, as heavy machinery and explosives became more readily available, mountaintop removal mining has become a possibility. This technique is especially damaging and controversial, as it often removes over 1,000 vertical feet of mountain, destroying the entire area.
All of these mining techniques remove a large volume of coal, leaving an unsettled void in the mountain. The disturbance of soil and rocks brings minerals to the surface where they can interact with water and air. Chemical reactions cause some of the minerals to dissociate and create acids in water. In turn, a portion of the acidic water reacts with the surrounding geological features, dissolving heavy metals such as copper, lead, mercury, and aluminum into the water. The runoff, containing high acidity and high concentrations of heavy metals, is referred to as acid mine drainage, or AMD.
During the 1940s, these coal mines drained over 170,000 pounds of acidity a year into the North Branch watershed. The most severe period of pollution in the 1960s occurred with the average of 120,000 pounds of acidity per day. Although 52 separate sites in the area produce AMD, 90% of the runoff can be attributed to 4 subwatersheds and 2 direct point sources.
Eventually, it became apparent that the runoff was causing significant damage to the ecosystem even further down the river. In 1981, the Jennings-Randolph Reservoir was constructed to allow for mixing of water qualities and control of water quality downstream. However, the reservoir did not prove effective, as the influent water was too contaminated to be remediated by this method.
In the early 1990s, however, it was determined that lime dosing was the best method to return the water to a habitable pH. Several lime dosers were installed along creeks that had been tested for high acidity. Eventually, once this method was improved, the pH of the river began to return to normal, and the ecosystem began to restore to its original state.
Today, the Potomac River is home to a wide variety of flora and fauna, and provides numerous recreational opportunities, as well as being the primary water source for millions of people in the Washington, D.C. area. If not for effective remediation attempts, the Potomac would have been unable to inhabit any wildlife and support a bright environmental future for generations to come.